Conversions, conversions, conversions! All right, so here we're going to do it today. We're talking about conversions. Now, in this conversion, you may have been taught conversions before, and with this, you may have had to multiply, divide. This version right here, we're going to have zero, and I mean zero, mathematicus involved here, right? No multiplying, no dividing, nothing. So, we're going to start off here, but first, before we do anything like that, I want you to take a look at this, and that is the wonderful world of pre-reading and post-reading. Take a look at these two words. What does pre-reading mean? Right? What does pre-reading mean? What does post-reading mean? So give me an example of pre-reading. Think of an example right now. Right? Pre-reading. You know, you're going to skim through it and see what the material is about. Post-reading. Okay, what's post-reading? Okay. May summarize something. Well, if I read the word pre-reading and I read post-reading, when I see the word pre-reading here, so when I look at this pre-reading here, how do I know that I'm supposed to skim and not summarize when I see this word pre-reading? And when I see post-reading here, how do I know I'm supposed to summarize and not skim? Well, that's this right here. This and this. The prefixes. The prefix of a word, these words help give this base word here, the base word of reading, a meaning. All right, in science, when dealing with conversions in the metric system, way, way easier than the English system. If I asked you right now, how many inches are in 1 mile, what'd you say? Go ahead, tell me, real quick. Yeah, no clue, do you? Now, if I asked you how many centimeters were in a kilometer, and a kilometer is kind of like a mile, and a centimeter is kind of like an inch, you could figure that out just like that in the way we're going to talk about the method we're going to talk about right now. Okay, so first of all, let's take a look at these prefixes. Prefixes are important. They help, like I said, give the word some meaning. So the first thing we're going to talk about here is the first prefix. Now there's a whole bunch of them that are out there, but we're just going to focus on this core right here. Kilo. Kilo has a symbol of K. Hecto has a symbol of H. Deca is 10. Now each of these has a numerical value. 10, 100, and 1,000 of a base unit. We're going to talk about more how we get those numbers in a little bit. Like I said, we're not going to do any multiplying here at all. So we're going to look at the next one is the base unit. Now the base, this would be like reading in our pre-reading, post-reading example. So the base unit would be things like meter, liter, gram, seconds, so forth and so on. Then we have deci, which is lowercase d, centi, which is a lowercase c, and milli, which is a lowercase m. Okay, so moving right along. Now, we take a look at a unit label. So here we have 10 centimeters. If I were to take and cover this up, you would see, if I just had the word number, let's say if I just had 10, okay? And I asked you, all right, I'm going to give you 10 of something. I'm going to give you 10. And you're like, okay, great. 10 what? But now if I said, I'm going to give you $10, like, oh, nah, that's so bad. I can handle that. What do I have to do? Or what if I said, I'm going to give you 10 paper clips? You're like, okay, great. 10 paper clips. Whoopie-dee. Well, of course, unless you collect paper clips, in which you're like, yay! But for right now, it's like, okay, 10. So a number by itself, remember, has just a value. It has no meaning. And it's the unit labels that we focus on that give the number some actual meaning other than the value of, okay, 10. But 10 what? So here we have, this right here is our good old unit label. It's made up of 2 letters right here. This is an example of one. Centimeters. The first letter is going to represent the prefix, and the second letter right here is going to represent the base. Are we talking about meters? Are we talking about grams? Are we talking about liters? What are we talking about? So, now, if by chance you just have a number here that has just only one unit, only one letter, that means it's going to be the base unit. Okay? A lot of times, one of the mistakes that will happen is that a student will say, oh, this means milli. No, that is not the case. All right? Anytime you have only one letter as a unit label, that's the base unit. And you don't say, pre in a sentence, just leave it just like that. You don't say, oh, I'm going to pre. Pre what? You don't know. All right? Just like this. So just like in your daily life, you're not going to pre something or just post and just leave it blank. You got to have some sort of base to it. You got to have some overall meaning. And that's this base unit. So a letter by itself means a base unit. Now, let's get some examples here. So the great thing about the metric system is that instead of having to memorize stuff like the English system, all you have to do is just slide the decimal point one way or the other. You go from over here, and you want to go somewhere else, you go slide it here. And you want to go from here, you just slide it over here. It's easy. So let's take a look at this right here. 1.8 meters. Okay, so now we got to find out, okay, where up, take a look at our chart at the top here. And we're going to say our M. So we just have one letter. That means it's a base unit. So we're going to start right here at the base. Now we're going to have to we're going to try to find out how many centimeters. So we're going to go to over here by centimeters. So we go start at the base unit, and we go 1, 2 spots to the right. So now what we're going to do is we're going to take our decimal point, take a look at this point here, and we're going to go 1, 2 to the right. It's super easy. It's unbelievably easy. Because all you do is you look at the chart here, you go from base, you move over 2 spots to the right, therefore the decimal point is going to move over 2 spots to the right, and there it is. Now, all of a sudden we've got this little loop. Now, anytime there is a loop without a number in it, we have to put in a 0. You have to put in a 0. So the answer here is, now I've put this number down below so we're not messing up on the top here, so it should be 180 centimeters equals 1.8 meters. Let's try another one. So I have 0.028 kilograms. Okay, so I'm going to start over here at kilo. And I want to find out how many, let's change that. How many grams? Let's find out how many grams there are. Typo, my bad. My mistake, here we go. So we start here at kilo. We go 1, 2, 3 to the right. All right. So now we take a look at here. We go, start at the decimal point here. We go 1, 2, 3 to the right here. And so the answer is 28 grams. So next try. Now on this one, now I have 2 dg. So I have decigrams. Remember, it's just deci is D and deca is DA. So now I'm going from deci right here, and I want to go to deca, which is over here. So I go 1, 2 to the left. Okay, so I went 2 to the left, so now I'm going to have to take 2 to the left. Now, wait a minute. I look at the number. Where is the decimal point? Now remember, in math, if there's no decimal point shown, you got to start at the last number, and it's located at the end of the last number here. So it's right here. So now I go 1, 2 to the left. So I'm going to take this decimal point and go 1, 2 to the left. I fill in any loops. So my answer is 0.02. Easy. So that was right here. I go 1, 2. And that's how it is. It's just that simple. You don't have to do any multiplying, no dividing. I just take a number. I find out where the decimal point is. I have to find out where I start and where I'm going to. So I'm going to have to find out where I start and what I'm trying to find out. And then all I do is just move the decimal point from one spot to the other. Easy as eating pancakes. And that is what we say finite. Or not. Or we can hit the button now, and now we'll stop.